Weather prediction has always been a challenge, but in the face of intensifying extreme weather events, the stakes have never been higher. Accurate, real-time data is no longer optional, it's essential, and it all starts with one key element: observations.
We're seeing these more intense flooding situations, more intense fires, eruptions that happen much more quickly than they ever have in the past due to much drier conditions. So the economy is basically begging for data, begging to have better weather forecasts so they know literally what's coming.
The big change for us as a company is that for 3 to 4 years we've been talking about space, but now we actually generate data from space.
The Tomorrow.io constellation fills critical gaps in global weather coverage, delivering crystal clear data at speeds once thought impossible.
No matter what you do, machine learning models or the new technologies that we are advancing, especially in machine learning, the data is key. And so they had gone and done a survey with a number of scientists, and the number one, the highest value was microwave sounders that can improve the weather forecasting across the. So Tomorrow.io had essentially decided that microwave sounders is going to be where they're going to focus on.
So obviously sounders are the backbone of weather models around the world. And I think that it is very clear that if we had this capability, if we had these measurements with high revisit rate, it would improve dramatically our ability to train models with real observations and not by training models on models like what most people do right now, as well as initialize these models with actual observations.
With our constellation, once it's fully in place, you can see there's hardly any gaps left because we're just going to have so many more satellites. They're going to have a wider swath, and we're getting specifically lower latency downlinks. So we're getting the data more rapidly. And so it's really going to be highly impactful in filling all these gaps of information that we currently have.
Sounders are one of the instruments that are capable of capturing the widest area in the shortest amount of time and give us a lot of information about that area.
So these like small motions in molecules create, frequencies, and we have specifically tuned our instrument to look at frequencies that align with what we're looking for, so temperature, humidity, and precipitation.
And so they fly in space in what's called low Earth orbit, so about 500 kilometers above the surface. And while they fly, they just listen to the radiation that's emitted from space at those frequencies, which are called microwave frequencies in the tens and hundreds of gigahertz. And based on that, they can tell us the profiles of humidity, temperature, water vapor in the atmosphere across a very wide swath. So when we have that information and we then feed it into our forecasting models, it drives huge improvements, huge benefit to the model because it gives it a lot of knowledge about what's going on right now. That's what sounders are in a nutshell.